In this video, we're going to learn to basically give names or go backwards and create formulas when we're using only prefixes. Now, in previous videos, we were dealing with ionic materials, meaning something from the metal side and the non-metal side of the periodic table. Now, in this case, when we're doing prefixes, we're typically only focusing on covalent materials, which usually means it's a non-metal and a non-metal. And so if we look at our periodic table from the New York State, again, this is for New York State chemistry, but if you look at any periodic table, reality, if we look at some of these elements, just at a quick glance, these are all non-metals. So nitrogen, oxygen, chlorine, fluorine, carbon, we got some repeats here, sulfur, nitrogen, carbon, silicon, phosphorus, xenon, boron. Okay, so either non-metals, metalloids, and so they're all found over here. And so they're typically all non-metals, but because the ability of non-metals is usually greater in attracting electrons, you often have one that will work a little bit better than the others, and they will still have a sharing of electrons instead of a taking of electrons. In ionic materials, one element gains an electron and loses an electron. You got a positive and negative ion that magnetically attracts to each other. But in covalent bonding, you have a sharing of electrons. And so we don't even need the crisscross method, and we do not even need any of the oxidation numbers. And so in our previous activity, we actually had to look up the charge, which is in the top right of the box in on your reference table, but this is totally different. If you notice on this activity, I know it's kind of blurred out there, but it says prefixes only. Now prefix, again, a little bit of just something that comes before a statement. And what we're going to do, we're going to come up with these numbers, and the numbers are here. So for example, the 3 and the 2 and the 4 and the 5 and the 8, those are going to be the numbers we're going to be dealing with. And if there's no number, that just means it's a 1. And so the prefixes we need to deal with, 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is pent or penta, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. Okay, so, or deca. And so when we go through these, so we could do octa, hepta, hexa, hepta, octa, nona, deca. And so when we go through these, there's going to be some change. Sometimes the last letter is removed. But when we look at these, we don't have to go through, we don't have to look up charges, we don't have to look up and do any crisscross, we don't have to reduce anything. Everything's already here for us. So when we look at these, if the first element by itself doesn't have a number, we do not need to use mono. The only time you need to use mono is on the second element, okay, the second element. And so one of the things that you want to be familiar with here, and this is number 10, that you hear about this in your household, and it is a danger for materials that do not combust correctly, for your furnace, for your garage, heaters, things like that. And what that is called carbon. The first letter, we're just going to use the same because it's an element by itself, so I'm not going to use a prefix. Again, if it's an element by itself, there's no number, I'm just going to write the element as it is. If there's other numbers, we're going to change that, and we'll give you some examples. But carbon, and now the second element, I do need to put a prefix based on the number because there's a number 1. This becomes carbon monoxide. Now, you may have heard of carbon monoxide as far as a colorless, odorless, deadly gas that can cause you to, it kind of does the same thing as oxygen does. It bonds onto your red blood cells and basically will reduce the amount of oxygen you get in your body, and therefore you get lightheaded and tired, maybe pass out, and potentially you could die. So it could be very dangerous. Now, you're all probably familiar with the one you've been seeing in many science courses for years, CO2. The only difference there, instead of carbon monoxide, this becomes carbon my prefix dioxide. So notice I haven't looked up any charges. I haven't figured out what number I'm using. I'm just using the prefixes that are available, carbon dioxide. Now, if we go up here and look, this one's a little bit different. This would be dinitrogen because there are 2 of them. So dinitrogen, and then monoxide because there's only 1 oxygen. So dinitrogen monoxide. I'm taking my prefix. I've taken the prefix because there's 2 nitrogens. So dinitrogen monoxide. If we jump down to this one, for example, we have P is phosphorus. So phosphorus. Roman numeral 3, or excuse me, not Roman numeral, but number 3 is tri. So trifluoride. Now you may need to look up names, of course, and remember, the second name for all of these is going to end in IDE. So whether it's fluoride, oxide, nitride, whatever you're going to use. Now, in each case, we only had one of them. Maybe we had a mono. If we go down here, look at this one, Cl2O7, that would be dichlorine, and then 7 would be heptachloride. So we have our 7 for hepta, we have our 2 for di. And so it's pretty straightforward when you have to take and use the prefixes to name them. And again, this typically, all of these are going to be covalent. That means nonmetal plus nonmetal. That's all we're using here. We're using just nonmetals, and we typically follow the idea of the prefix rules and not the crisscross method. So you have to be careful what you're being asked for. You have to be careful and look for the materials. If you see a metal and a nonmetal, you're going to use crisscross method, and you're going to use oxidation numbers, and you're going to use the stock system. But if you're using nonmetal and nonmetal, which is covalent, then you're just going to use prefixes, okay? Unless somebody tells you otherwise, okay? Unless they tell you otherwise, that's what we're going to do. Now, the second part of this video, let's see if we can find, I believe I have some examples going the other way. If it's not on this sheet, I have another sheet here. There we go. Actually, this one doesn't. So this one again is notice we see ATEs and ITEs. So let's go back to that sheet, and for example, I'm just going to go and I'll put a couple examples here just to show you what's going on. So I'm just going to cover this bottom portion, and we'll just use some of the available space down here. And so let's say, for example, I had tetracarbon pentoxide. Now, this may or may not exist. I'm just kind of making this up at the spur of the moment. It should be pretty easy because you're just going to look for the prefixes, of course, and the actual symbols. So tetra is 4, so carbon C4, and then pent or pentaoxide. A lot of times you don't see the two vowels together, A and then O. C4O5. Again, I'm just making that up just to throw something out of what you may see out there. Another one you see, carbon, or you'll hear about in regards to like ozone depletion. Make sure I'm spelling right. Carbon tetrachloride. Sorry about that. Carbon tetrachloride, so because there's no other prefix, it's just one carbon. Tetra is 4 chlorines. Chloride is chlorine. So you should be able to go both ways, given symbols or formulas, and then give names. Or if you were given names, you should be able to give symbols. So hopefully the prefixes makes sense, and you are able to maybe find that a little bit easier than you were with the Roman numerals. So keep taking action, and I look forward to seeing your results.